today we are going to discuss about this lending and borrowing portfolio, how you divide this lending and borrowing portfolio based on the capital market line is represented in this particular chart. Right? Again, let me explain this. The upper part of the curve where you have a return higher than the market portfolio, that portion we are calling that portion as the borrowing portfolio. Right? The lower part of the curve, the line, lower part of the line, which represents the expected returns than the market portfolio, we call it lending portfolio. So I have given two examples of lending portfolio and borrowing portfolio. Now, if you look at this, the point C, it represents the lending portfolio. Point E represents the borrowing portfolio. Right? Point C represents a lending portfolio and point E represents a borrowing portfolio. Let me explain why we call those two portfolios lending and borrowing. Right? Okay. So now again, you might wonder why we are discussing these two. Is there any relationship to the market? Because now if you remember, when we are developing this capital market line, we already identified this market portfolio, right? We already identified this market portfolio and right, and we call it the portfolio that has a minimum risk, because market portfolio consists with all the investments available within the market. So that means all the diversifiable risk, the risk that we could diversify, it is already diversified in the market portfolios. So when it comes to capital market line, we are only investing in the risk-free asset and the market portfolio, right? Risk-free assets and the market portfolio. The combination will change when you are moving along the line. The combination will change when you are moving along the line, right? When you are moving from risk-free rate to market portfolio, the weights of the risk-free rate always will give you a positive value. When you are going above the market portfolio, the sign of the risk-free rate or the weight of the risk-free rate will become negative. So let me explain that. Now, why this is happening is actually, now if anyone want to, as we identified, the best portfolio to invest here is actually market, because it gives you the highest risk premium for a given unit of risk, right? So what if there is an investor that he doesn't want to go for that much of high risk? Now, for example, if there is an investor who don't want to go for market risk because he feels that this is too much high for him, too much high. So instead of going for this risk, what if he goes for the standard deviation C here, something lower than the market portfolio, right? Something lower than the market portfolio. So that means he is looking at this amount of return also, right? So if that is the case, what are the weights that we should invest on? How much we are going to invest on the risk-free asset, how much we are going to invest on market portfolio, right? So that is what we are going to discuss today. Now if you look at the points here that I have given, right? Now this point says that one way would be to invest in one of the risky portfolios on the Marquis frontier beyond the point M, such as portfolio at point D, right? Now it says that, now if we now here it is less than lending portfolio. Now here we are discussing about again a borrowing portfolio. Now here, on the other hand, now here we discuss what if an investor wants to bear a low risk than what is available on the market. On the other hand, what if there is an investor who need to bear higher risk than the what is available on the market, or higher return than the what is available on the market portfolio. Likewise, a point E or maybe point D, right? So something higher than the market portfolio. You get a return higher than the market portfolio if you go for D, and even better if you go for E, right? So if that is the case again, then that type of portfolio we call it borrowing portfolio. So let me calculate the borrowing portfolio and lending portfolio here. If you all remember, so this is the formula that we discussed earlier, this particular formula, right? Expected return of the uh, portfolio is equal to weight of the risk-free asset and rate of the risk-free asset plus 1 minus weight of the risk-free asset. That means actually the weight of the market portfolio, right? As we all know, there are only two portfolios here, risk-free asset and the market portfolio, two assets. So we only have two weights, weight of the risk-free asset and the weight of the market portfolio. So we can identify this part as the weight of the market portfolio, because 1 minus weight of the risk-free asset is also equal to weight of the market portfolio, right? So here how we are going to show this particular investment in the equation is like this. Now the second alternative here, we are going, if we are going to D, now as we all know, no one is going to invest on portfolio D, because for the same level of risk, E will give you the better performance. So no one is going to go for portfolio D, so I am going to remove it. So if you look at the portfolio E, now how the question here is, what is the combination of the weights of market portfolio and the risk-free rate, so that we can reach this point E. So let me calculate it. So how we are going to do is if you want to go for this much of return, now how you are going to identify this borrowing portfolio, like this. If you borrow an amount equal to 50% of your original wealth at the risk-free rate or the point E, the weight of the risk-free will not be positive, but rather a negative one. As I explained, if you go beyond the market portfolio, the weight of the risk-free asset will be negative. Let me explain why. Now this is how it is going to happen. Negative. Now if the portfolio construction is 50-50, for example, let's say you have 100 rupees to invest today. So that is the total value of your portfolio, 100 rupees. If that is the case, you can invest all the 100 rupees on your market portfolio. All the 100 rupees on your market portfolio according to the capital market line, because market portfolio is the one give you the highest return for a given level of risk. Actually, to be precise, highest excess return, right? So therefore, I am going to invest all of my money on the market portfolio. But by investing all of my money on the market portfolio, I am only getting this much of risk. Sorry, this much of return and this much of risk. But I need to go to the, I really need to go to this point in terms of risk, in terms of return, and in terms of risk, I need to go to this point. So how I am going to reach point E? So that is the main concern here. So how we are going to reach point E? You are going to borrow some money at the risk-free rate. For example, imagine that risk-free rate is 1%. If the risk-free rate is 1%, that means I am going to borrow some money from the economy or from a bank or whatever place. I am going to borrow money at the risk-free rate then invest that money also on the market portfolio. Invest that money also on the market portfolio. So that way I can easily reach the portfolio E here. So that's why the value here, the weights of the return of the risk-free asset is considered as a negative value, because I don't have the money right now, but I am going to borrow that money from someone else from outside. So therefore I am borrowing that amount of money from someone else, and total investment of the expected return of the market would be equal to 1.5. How? I already have one. That is the amount of money with me right now, and I am going to borrow 0.5% of whatever the available with me from outside. For like now, as the example, if I have 100 rupees, I am going to borrow another 50%. That means 50 rupees from outside. That means I have altogether 150 rupees with me to invest. Sorry. So that 150 rupees I am going to invest on the market portfolio, and that will give me the expected return of point E, not the expected return at the market portfolio, but expected return of the point E, because I get the premium here. Now, what is the premium? The premium between risk-free rate and the market. Premium between risk-free rate and the market, because I am going to borrow money at the risk-free rate and invest at the market portfolio. So this is the cost that I need to bear, the risk-free rate. But by borrowing that money from the risk-free rate, I can invest it on the market rate. Just imagine, as I said, risk-free rate is equal to 1% and market rate is equal to 10%. So that means you are going to borrow money at risk-free rate, that means 10%, 1%, and you are going to invest that money at 10%. So there is a difference of 9%. That difference is actually your profit. Because of that difference, you can easily achieve this level of return. You can easily achieve this level, in the sense the level of return that is given in the point E, right? So you can easily calculate like that uh, the level of return that you are going to receive at the lending portfolios and the borrowing portfolio. So what is the difference between lending and borrowing portfolio? When it comes to lending portfolio, you need to go for lower risk. So what you do is you are going to invest fraction of your money at the risk-free rate and the another fraction at the market portfolio, right? So that's why it is a lending portfolio. So the portion of your money is going to be lent to outside at the risk-free rate. You are going to lend your money at the risk-free rate, and portion of your money is going to be invested on the market. So therefore you can go around here. You will be receiving a rate of return, here, and corresponding to this much of risk, right? So that's why this is lending. Now when it comes to this portion of the CML, you always lend your money outside, but when you are going beyond the market portfolio, you cannot lend. Instead of lending, you will have to borrow from the outside. So therefore, when you are going beyond the market line or the market portfolio, you will be expecting more return than the market portfolio. But if you are below the market point, that means you are expecting a return below the market portfolio. So that is how you identify lending portfolio and the borrowing portfolio, right? So let me explain this with the example, so that you can identify and calculate what is the exact ways that you want to invest on these two type of assets, right? So let me go into the calculation. Uh, can you all see this sheet?
Yes, sir.
So please pay your attention to this particular Excel sheet. Now you can see I have given you the same graph here. Same graph. Uh, Here, the same graph. So we have lending portfolio and the borrowing portfolio. We have point E and point C, right? So with this, I'm going to go for the calculations. Right, now here, as we discussed, one alternative would be point E. So if you discuss about point E, now what we are going to do, right? In the point E, just imagine that, please read this out here, this particular statement. Now here what we are going to do is, we are going to borrow money, an amount of equal to 50% of your original wealth at the risk-free rate, and a weight of the risk-free will not be positive fraction but rather negative, that we know. So this is the information we have right now. Risk-free rate is equal to 6%, expected return of the market is equal to 12%, and the standard deviation of the market portfolio is equal to 3%, right? The return on your leverage portfolio is actually the borrowing portfolio, right? It is the borrowing portfolio. So we are going to calculate that, right? Okay. So these are the equations we have. We already know these equations. We already discussed about those things. So if this is the case, how we are going to identify the expected return of this borrowing portfolio, which is actually this point E, right? So let me calculate that. Please follow the calculations with me. So I'm going to calculate that value here in this particular cell, right? So what I am going to do here is this. Now, you know, we are going to borrow money at E, point E. That means we are going to borrow 50% of our money, 50% of our original wealth from the outside. So if our original weight is equal to 100, that means 50% we are going to get from outside at the risk-free rate. So therefore, the weight of the risk-free rate is equal to 50. Weight of the risk-free rate is equal to 50, right? Therefore, weights of the risk-free rate is equal to 50, and the weights of the expected return is equal to 1.5, because we are going to invest whatever the amount that we have borrowed and whatever the amount that we have with us right now. That means 0.5 from the outside we borrowed, and we had 1. So 1 plus 0.5, altogether we have 1.5 to be invested in the market portfolio. Now there is another criteria you can understand this. The summation of these two weights, it should always be equal to 1. The summation of these two, right? If you have negative value here, and then you should have a value more than 1 here, because the summation of these two always should be equal to 1, like this. So negative 0.5 plus 1.5 is equal to 1, right? So all I have to do here now, I can substitute the value here. Now we have 0 minus 0.5 multiply by risk-free rate. So I'm going to multiply it by risk-free rate, multiply. We know the risk-free rate is given here, it is 6%, 0.06. right? And here we have expected return of the market. That means 1.5 multiplied by expected return of the market is also given. See, expected return of the market is 12%. So I am going to set 0.12. So this is how you calculate the expected return of the portfolio of the combination of risk-free asset and the risky asset. So let me calculate that value here. Equal negative 0.5 multiplied by 0.06 plus 1.5 multiplied by 0.12. So you get 15%. So value here is equal to 15%. 15%. Right? So this is how you calculate the expected return of the borrowing portfolio. Expected return of the borrowing portfolio. Then we are going to calculate the expected return of, then we are going to calculate the standard deviation of the borrowing portfolio or average leverage portfolio. So this is the formula for expected standard deviation. This is the formula for standard deviation. So I hope that you will remember how we derive this formula, right? How we derive this formula. We kind of derive it in this particular so this is how we derive this. Can you all see this formula?
Yes, sir.
Right. Now, if you look at this formula, this is the formula to calculate the standard deviation. Here we have variance. So you get this square root of this, you get the standard deviation. So now, as we all know, when it comes to risk-free rate, right? When it comes to risk-free asset, the standard deviation is 0 because risk-free asset, why we call it risk-free asset, because the standard deviation is 0. So that is the basic idea. There is no risk when it comes to risk-free assets. So if you identify this asset 1 here in this formula, asset 1 to be risk-free asset. So let me rename it. Asset 1 is risk-free asset. If that is the case, you get like this. RF and asset 1 should be here, it should also be RF. So this is how it comes. So according to this formula, so you get RF, weight of the RF multiplied by weights of the RF multiplied by variance or the power 2 of the standard deviation or the variance of the standard deviation. So as we all know, since the standard deviation of the risk-free rate is equal to 0, that means the variance is also equal to 0. So that means this whole part is going to be equal to 0. So something multiplied by 0, it is also equal to 0. I am going to put 0 here, right? And again, since the standard deviation is equal to 0, the covariance between these two assets, that means risky assets and the risk-free asset, is also going to be equal to 0. So again, something multiplied by 0 is equal to 0. This whole part becomes 0 again, right? Okay. So this is how it comes. So I'm going to get rid of these 0 values. So you get this part only, right? So here, if you can identify, that means weight of the market portfolio. Here the second portfolio is the market portfolio. Weight of the market portfolio multiplied by standard deviation power to 2 of the market portfolio. That means variance of the market portfolio. So this particular formula is given here. So only difference that I have done here is, instead of this weight, I have only used, instead of this, I used 1 minus weight of the risk-free rate. That I think you can understand. This 1 minus RF is actually equal, this portion is actually equal to, this portion is equal to weight of the market portfolio. Weight of the market portfolio. Right? It's the same thing. Weight of the market portfolio is equal to 1 minus weight of the risk-free asset. Risk-free assets, the same thing. Right? 1 minus risk, it's the same thing. So we can get rid of these power to 2, second power for all, from all the variables here, because we can get rid of that because we have same power here. So we are going to end up with this particular equation, right? So that's how you derive that equation. So in this equation, now I know, according to previous calculation, we have a negative 0.5 weight when it comes to the weight of the market, weight of the risk-free asset. So I am going to add that one here. So here one negative and positive. That means one negative and positive means that is going to be negative and positive. Again, it is going to be negative. Sorry, we have one negative and again negative 0.5. That means two negatives means it is going to be positive. So 1 plus 0.5 multiplied by the market standard deviation. So I am going to calculate the value here. Standard deviation of the portfolio is equal to 1 plus 0.5 multiplied by the standard deviation of the market portfolio is given in the sum. It is equal to 3% here. It is equal to 3%. So 0.03. So you get 4.5 as your 4.5 as your standard deviation. Now this means that here the value at the point of E here, the standard the risk the return here is equal to 15%. It is equal to 15%. And the standard deviation is equal to 4.5%. Okay. Standard deviation here is 4.5%. The return of this particular portfolio is equal to 15%. So that is what we have calculated here, right? So let me go to the lending portfolio instead of borrowing portfolio. So I am going to go for the second example here. So this is the second example. So you can read this out. On the other hand, what if an investor wants to, on the other hand, but if an investor wants to maintain a lower risk than what is offered by the market portfolio, that means around point C, right? So you can either go for A, you don't want to go for A, you will go for C here. So if that is the C, that means that you are going to lend 50% of your money. You are going to lend 50%. It is not always the 50%. You can lend if you want 40%. If you want 20%, that depends on the point that you are on here. Now here we are just assuming that we are going to lend 50%. So In later we will discuss how we are going to identify the weights with more complicated sum. Now here just imagine that we are going to lend 50% of the money at risk-free rate, and the rest of 50% is going to be invested on market portfolio. So if that is the case, again, as earlier, uh, we have these two formulas, same formulas. So we have 0.5. This time it is positive because we are going to lend. We are not going to borrow. So 0.5 multiplied by risk-free rate plus the rest of 0.5 multiplied by expected return. Here also our rule is already verified because 0.5 plus 0.5, again it is equal to 1. Now earlier also it is the same case. Negative 0.5 plus positive 1.5, that means it is equal to 1 also, right? So I am going to calculate the value here. It is pretty easy for us to calculate now. Equal 0.5 multiplied by the risk-free rate. Risk-free rate we already have, it is 6%. So I am going to add 6% here, 0.06 plus 0.5, that is the rate of the market return. So the market return is given 12%. It is 12%. So I am going to add 0.12. So you get a return of so you get a return of 9%. Return of 9%. So let me calculate the standard deviation also. I am going to use the same old formula. So here 1 minus, so weight of the risk-free asset is equal to 1 equal to 0.5. That means we have 1 minus 0.5 multiplied by standard deviation. So let me calculate that value here. 1 minus 0.5 multiplied by standard deviation was 3% here. So I am going to add 3%, 0.03, right? So this is the answer. 0.03, this is the answer. So 1.5. That means the values here. So let me put the values here and here. We already calculated those values, right? So the value here was 15%. And here we already calculate the value now, it was 9%. And risk-free rate is equal to how much? Risk-free rate is equal to 6% according to the sum, right? And these values also we already calculated here. Here the standard deviation was 1.5%. And here we calculated the standard deviation, it was 4.5%. 4.5%. And the standard deviation for the market, it was given, it is 3%. So this is how it comes. This is how it comes. So you can now clearly see, if you are going to invest on the market portfolio, right, you are going to get a return of 12%. That is also given in the sum, 12%, right? So If an investor needs to go for a higher return than the market portfolio, that means he will have to go for a borrowing portfolio, right? If he go for a borrowing portfolio, he can always reach the point E, right? Point E. Then he can go for 15% of return so that he can increase the return. If there is an investor that he don't want to go for 12%, he need less than 12% so that he can go for 9% by going into a lending portfolio. Going into a lending portfolio means here the 50% of my money. Imagine that I have 100 rupees. I am going to invest 50 rupees on the market portfolio and another 50 rupees at the risk-free rate. At the risk-free rate, right? So it is easy, 50-50. So I am going to invest on 650 and 1250. That means 12 plus 6 is equal to 18. 18 divided by 2, you get easily your 9%. 18 divided by 2, that means it is 9%. So on the other way around, if there is investor who wants more than market return, he can always go for borrowing portfolio. Borrowing portfolio means that you will have to borrow some money at the risk-free rate. That means you are going to invest your whole 100 rupees. That means all of your total original investment on the market portfolio at 12%. And you are going to borrow another 50 rupees at 6%. And again, you are going to invest that at the 12% rate in the market portfolio. So altogether, you are going to invest 150 rupees at 12%, and you are going to borrow 50 rupees at 6% so that you can achieve a level of return of 15%. So that is the main idea here, right? Then I am going to move into the little bit of a calculation here with this example so that you can further identify the calculations and understand the theory behind the uh, market portfolios and lending portfolios when it comes to capital market line. So please, all of you, read this example. Please read this. Suppose that you have estimated the investment characteristics of 6 different combination of risky assets which are listed below, right? Then these portfolios are completely diversified so that its volatility estimates represents only the systematic risk. The risk-free rate is 6%. The risk-free rate is 6%. I will explain this systematic risk and unsystematic risk at the end of this calculation. So for the time being, you just understand that systematic risk is the risk that is available in the market. That is available in the market, which we cannot diversify. But unsystematic risk part, we can always diversify by creating better portfolios. So as we know, the market portfolio consists of all the risky assets that are available on the market. That means the market portfolio is already diversified up to a maximum level. Therefore, nothing left there to diversify. So the only risk that is presented is the systematic risk or the undiversifiable risk. So that is what you have to understand here. The diversification part, I will explain it little bit later. Now, for the time being, according to this particular example, we have this information. So we have altogether 7 portfolios. Portfolio 1, 2, 3, 4, 5, 6, and 7. And expected returns and the portfolio standard deviations also given here. 8%, 10%, 11, 15, 17, 20, and we have the standard deviation also. Right? Understood? Now what I am going to do here is I am going to calculate the Actually, I am going to uh, estimate the slope of the capital market line here. So that way I can calculate the, I can identify the market portfolio and the other portfolios which are available for us, right? So let me get that equation from the capital market line. Right, so this particular equation here, can you all see that? Can you all this equation?
Yes.
Right,
Yes.
this particular equation here, what I am going to do is I am going to calculate this slope part of the equation. So other two you already know, this is the risk free rate and this is the standard deviation of the portfolio. So the risk free rate is already given here, it is 6%, and standard deviation of the portfolio is also given here. Look at this, it is given 7%, 8%, right? So I am going to calculate this middle part, the slope. So how you calculate that? You get expected return of the market portfolio minus risk-free rate divided by the market portfolio. So what I am going to do is, instead of market portfolio, here I am going to put the portfolio standard deviation. Instead of market portfolio standard deviation. So you will understand why I am going to use like that once we do the calculation. So let me do the calculation here. So here equal expected return of the market, I am going to use this, right? Expected return of the market minus risk-free rate is equal to 6%. It is given in the sum 0.06 divide by standard deviation of the portfolio here. So you get this value. So I am going to drag the equation down, so you get answers for all the things, right? So you have these slope coefficients, right? So, and now the main thing you can do is actually to identify the market portfolio here. The risk-free rate we already know, that is 6%. That is equal to 6% risk-free rate. Now, how we are going to identify the market portfolio here? Now, as we all know, if you look at this particular graph, this is the same graph that we are discussing for very long time. So this particular graph, you know, the maximum slope occurs at the point of market M or the market portfolio. That's why we have a tangency occurring at that point. So the maximum point of the maximum slope of this particular efficient frontier is actually at the point of M, right? At the point of M. So that is where the slope of the CML gets equal to the slope of the efficient frontier. So or the efficient mean efficient frontier. So there is a slope for the mean efficient frontier, it is a curve, and there is a slope for the capital market line. When those two slopes gets equal to each other, you get this tangency. So at the point M, slope of the capital market line is equal to the slope of the efficient frontier. So that's why there is a tangency point here, right? So in this point, we get the maximum value for the slope when it comes to the efficient fund creation. So all you have to do is now identify the maximum value out of the portfolios that are given for us. Now here, what is the maximum value here? How you identify easily from Excel, you can do it max. Then you give the range, then it will give you the maximum value, that is 0.9. So this is the maximum value that you can get for the slope or the slope of the efficient frontier or the slope of the here actually the slope of the efficient frontier is equal to the slope of the capital market line. So you can take this as the slope of the efficient frontier as well as the slope of the capital market line. So in this point according to this graph, in this point you have a slope of 0.9 when it comes to capital market line as well as when it comes to efficient frontier. So the highest slope is here. So that's how you identify the market portfolio. So this portfolio can be identified like the market portfolio. So this is the market portfolio. So I am going to take this 15% here because that is the value of, that is the expected return of the market portfolio, and standard deviation of the market portfolio is 10%. So that's how you identify the market portfolio from the set of portfolios that are given to you. How you get the maximum slope? You get the maximum slope. So with the maximum slope, you can identify the market portfolio, right? So now the next thing that you want to understand according to the slum, this information is also given to us. Please read it. Suppose based on your risk tolerance, you are willing to assume a risk of standard deviation 9%. How you should go about investing your money according to the CML. Now this is the main concern that we have. Now according to your risk preference, you are happy to bear a risk of 9%. This is just an imagination, right? Just think that you are happy to bear a risk of 9%. If that is the case, what is the uh, portfolio you are going to select? Can someone tell me? If your risk is now you have the series of expected returns and portfolios, and all the characteristics are given here. From we have portfolio from 1 to 7 portfolios, and expected returns and the risk or the standard deviation of the portfolios are also given, and we already identify the market portfolio to be 15% and 10%, right? So then with this information, can someone tell me, if you need to bear a risk of 9%, what is the portfolio you are going to select? What is the portfolio you are going to select? Any idea? So there are only 7 portfolios. Any guesses out of these 7?
Third one.
Third one, right? So why third one? Because it gives us a 9% of standard deviation. So we are happy to go for third one, right? So if you are only looking at the efficient frontier, that means you are going to select the third. That means you are going to select the third portfolio because it will give you 11% of return for about 9% of standard deviation, right? So that is given in here in this line. You could realize an expected rate of 11% if you place 100% of your funds in the portfolio 3. In the portfolio 3. However, you can do better than this by following the investment prescription of the capital market line. So this is the beauty of the capital market line, right? So let me introduce you the capital market line at this point. So this is the equation for capital market line, expected return of the portfolio is equal to risk-free rate plus expected return market minus risk-free rate divided by standard deviation of the market portfolio multiplied by the standard deviation of the portfolio. So what I'm going to do is I'm going to calculate the expected return at the maximum return you could expect for a corresponding level of risk that you can bear. Now, what is the maximum risk that you can bear? It is 9%. It is given here. But if you go for the efficient frontier, you can get 11% here. You can get maximum of 11%. Now, what I am going to do is I am going to calculate maximum return that you can get from the capital market line if you have 9% of standard deviation. So what I am going to do is I am going to add all these values here. So risk-free rate we know 0.06 it is given plus. So the middle part we have market expected return. Market expected return we already identify it is 15%. So 0.15 minus we know the expected we know the return of the risk-free rate 0.06 and divided by market standard deviation that we have identified here, it is 10%, 0.1. So that is the middle part, 0.1, because market we already identified the market, 15% expected return, standard deviation is 10%. And multiply that whole thing by standard deviation of the portfolio. Now, the standard deviation of the portfolio is what we are referring here. Now, we are happy to bear a 9% of standard deviation, right? So, I am going to add that 9%, 0.09 here. Now, if I am going to hit the enter button, right, there is some problem. If you are going to hit the enter button, you get 14.1%. 14.1% as the expected maximum return that you can earn from the capital market line. But if you invest that on the portfolio 3, you can only receive a return of 11%. But if you instead invest on the capital market line for the same level of risk, that means 9%, you can go up to 14.1%. 14.1% for the same level of risk. So that is the beauty of the capital market line. So how you are going to achieve this 14.1 is actually the next question. That is basically by manipulating the weights. That is basically by manipulating the weight. So let me calculate the weights here so that we can achieve this 14.1% of expected return, right? So now if you look at the next point here, now we can find the investment strategy, that means weights necessary to achieve this return by solving the below equation. Now we all know this particular equation from the previous discussion. So what I am going to do is I am going to identify this weight of the risk-free assets here, weights of the risk-free asset, right? So for that particular purpose, I am going to calculate the I am going to substitute all these values that I have calculated here. Now I have calculated the expected return, that means maximum expected return that we can expect from the capital market line. It is 14.1. So I have put that 14.1 here instead of expected return. Then we have weight of the risk-free rate, multiplied by the risk-free rate. So as we all know, risk-free rate is equal to 6%. It is given here in the particular example, 6%. So I am going to put that 6% here, right? If you want, you can put 0.06. This is also okay. And plus, let me put a bracket here so that it will be a little bit clear for you. And plus, we have 1 minus weight of the risk-free rate multiplied by expected return of the market that we already identified. It is 15%. So I am going to put 15 here. So all I need to do here is actually solve this particular equation. It is pretty much easy. So how we are going to solve this? So let me show it here. So we have here, that means we have 6 multiplied by weight of the risk-free asset, and when you multiply this by when you are getting rid of these brackets, you get 15 minus 15 multiplied by weight of the risk-free asset. So this is how you simplify this. Now what you are going to do is you are going to take that negative this positive 15 into the other side, this positive 15 into the other side. So it will become, this is very easy. I am just doing this for the understanding of viewers. So once you get this 15 into this side, that means 14.1 minus 15, right? So 14.5 minus 15 means it is equal to negative 0.9, negative 0.9. So you can get rid of this positive 15 here. So this is how it comes, right? So again, once you solve this part, 6 WRF minus 15 WRF, that means the whole part is equal to again 9. That means 15 minus 6, negative 9 WRF. So how you calculate the answer for WRS? It is pretty easy. So all you have to do is divide this negative 0.9 by 9. So the answer you get negative 0.9 divided by negative 9. So you get 10%. You get 0.1. So if you add the percentage value here, that means it is 10%. It is 10%. So this is what we calculate. So what does this mean? Now, when you have a 10% of expected return, 10% of weight, when you have a 10% of weight, for the risk-free asset, you can achieve a return of 14.1. You can achieve a return of 14.1. So that is the main idea here. That is the main idea. Right? So how you calculate this value? You can easily use the same formula here. So expected return is equal to right? Expected return is equal to, you can use the formula here. The weight of the risk-free asset we just calculated, it is 10% here, this one, multiply by the risk-free rate, it was 0.06, plus 1 minus weight of the risk-free rate, it is again 10%, multiply it by the return of the market portfolio, that is 15%, 0.15. So you get the same answer, 14.1%. 14.1%. Again, if you want to calculate the slope is going to be always the same, because as we all know, if it is a straight line, when it comes to capital market line, it is a straight line. Therefore, slope along the line, it is always going to be similar. So the slope is equal to the expected return. Here is 0.15, that is market expected return, minus 0.06 is the risk-free rate, divide by market risk. Market risk we already identified, it was again 10%. So divide by 0.1, it is 0.90. It was the same value that we calculated earlier. So no difference here. Right. So this is actually a lending portfolio. This is actually a lending portfolio where you can go for higher return. A lending portfolio. So how you identify this lending portfolio? The 10% of your funds in the riskless assets and the remaining 90% is in the portfolio 4. So that's what we are going to do. Since we identify this 10%, that means we are going to invest 10% of our money on the risk-free asset. That means at 6%. And rest of the 90% on the capital market, on the market portfolio, that is actually here in this particular 15%, right? So that's how you calculate the weights for this lending portfolio. So let me calculate another weight for the for a borrowing portfolio also, right? So according to this particular example, now again I am going to assume a separate risk level. What would happen if you were willing to take on a risk level of 14%? So I need to go for higher risk. Now if you look at the market risk here, it is 10%. Market risk is 10%. Now earlier when you calculating lending portfolio, we assume a risk of 9%. We assume a risk of 9%. But now I am going to assume a risk of 14% so that we can go for a lending portfolio, right? So lending portfolio again. So as I said earlier, now if you do not look at the possibilities on the capital market line, we will straight away go for this, because for 14%, I can always get a 17% return here. For a 14%, I can always get a 17% return here, right? But now if you look at this, if you want to go more than 17%, obviously you will have to look for capital market line. So we will discuss how, right? Here again, the same way that I did, I am going to calculate the maximum expected return that I can earn from the capital market line if I am going to take a risk level of 14%. So it is easy. Equal risk-free return, we already know 0.06 according to the sum, plus capital market line, that means the market rate or the expected return of the market, it was 15%. It was 15%, and again risk-free rate we know 0.06, and we are going to divide all this. We are going to multiply this part by, sorry, we are going to divide this part by what? Market portfolio. Market portfolio we already identify. It is expected return is 15 and 10. So we need to market the expected standard deviation of the market portfolio. So we have 10%, 0.1, and this whole part is going to be multiplied by the portfolio return, sorry, the portfolio standard deviation that we have already assumed. It is according to this, it is 14%. According to this, it is 14%. So I'm going to put 0.14 here. 0.14 here. Right? So if you get the value, you are going to end up with 18.6 here. 18.6. Now you just imagine this. Now, when you are assuming 14% of risk, you can go up to 18.6 of return if you are going to invest on the capital market line. But if you look at the formulas or the portfolios given for us, when you are assuming 14% risk, you can only go up to 17% risk. 17% risk. But if you go to the capital market line, the beauty of the capital market line, it will give you 18.6 for the same level of risk. So how you calculate the weights? Again, same way. Same way. So what I'm going to do is I'm going to substitute this 18.6 into the same formula. So 18.6 is equal to weight of the risk-free rate multiplied by 6. 6 is actually the risk-free rate plus 1 minus weight of the risk-free asset multiplied by 15. 15 is actually the expected rate of the market portfolio. Expected rate of the market portfolio. Right? So only difference here is from the previous one is actually this value 18.6 instead of 18.6. 14.1 I am going to put 18.6. Right? So again you will have these values. So you have 6 into this plus here 15 and 15. Right? So this is how it comes. So once you solve this particular one, you can always get the weight value here. So how we are going to solve it? So again, it is easy. So you get this 15% there. So that means 18.6 minus here, you get 18.6 minus 18.6 minus 15. Right? So that means the answer is 3.6. 3.6. From this side, you have again minus 15, minus 15, minus 15 and positive 6. That means you have minus 9. So you get here you get 9. Here you have 3.6. So the answer is equal to 3.6 divided by negative 9. Negative 9. So you have minus 0.40. Now you know this is a borrowing portfolio because you get a negative value. You get a negative value for the weight of the risk-free asset. So now you can calculate the expected return here using the same formula. So how we are going to calculate it? This is equal to weight of the risk-free asset, it is minus 0.4 multiplied by risk-free rate 0.06 plus 1 minus weight of the risk-free asset, it is again negative 0.05 multiply it by the weight of the portfolio, multiply it by the market portfolio standard deviation. It is market portfolio return, sorry, it is always 15%, so you get 0.15. So you get the same answer, 18.6, 18.6. So that means the combination here is actually you are going to combine like this. So 100% you are going to invest 140% of your money on the market. So market, you are going to invest 140%, right? On the risk free asset, you are going to invest negative 40%. So this is the strategy. So you can see it here. This means that you will have to invest 100% of your money. That means total of your money of funds and another 40%. That means 100 plus 40 borrowed funds in the portfolio 4, so that you could expect to earn 18.6%, and the expected risk premium per unit is always 0.9. As I said, if you want to calculate the slope coefficient here, it is again the same. How? 15 minus 6 divided by 10, it is 0.9. It is the same thing. You can see 0.9 here, 0.9 here, 0.9 here, 0.9 here. So that is the market portfolio. So now you can see the importance of the capital market line. If we do not have the capital market line, if we do not introduce this risk-free asset into the equation, you would not be able to earn 18.6 for a given level of risk, 18.6 of return for 14% of risk. Instead, you can earn a return of 17% for a 14% of risk. Same thing when it comes to lending portfolio also. If you do not have a capital market line, for 9% of risk, you can only earn 11% of return. But if you have the capital market line, that means for 9% of risk, you can earn a 14.1. You can earn a 14.1. Now you can see it is always less than the capital market or the market portfolio. Market portfolio is 15%. Now here it is only 14.1, less than the market, but again higher than what is available for the level of risk, more than 11%. Here for 17, instead of 17 for 14, you get 18.6. So that is how you prove that capital market line is superior to the efficient fund yield. Right. Okay. Now I am coming back to discuss this risk diversification and the market portfolio theory. So this is actually like a summary, right? So the investment idea that we discuss in the capital market theory is very straightforward, because why? We have only two type of assets. We have risk-free assets, we have risky assets, risk-free assets and the risky assets. So invest risky assets, we call it as the market portfolio or the market assets, the portfolio that consists all the assets, all the investment in the market, that is the market portfolio, right? So we have risky asset and the market portfolio. We only have two type of assets, right? And the weights of these two holdings determined by the investor's tolerance of the risk. So the weight is determined by the investor's tolerance of the risk. That's what we did here. Now the tolerance of the risk when it comes to the lending portfolio is 9% here. See, we just imagine that 9%. So our tolerance is 9%. If the tolerance is 9%, that means you can go up for a 14.1% of return. When it comes to the borrowing portfolio, our tolerance is 14%. If it is 14%, you can go up for a 18.5, sorry, 18.6. as we all know, higher the risk, higher the return. The relationship is always there, the positive relationship. So you get higher standard deviation, that means you are going to go for a higher return. Here is the same. For 9% it was 14.1. For 14% we get 18.6. So it is the case when it comes to the capital market theory also, right? As I said, the market portfolio holds all the investors. It must contain all the risky assets for which there is any value in the marketplace. So marketplace, if there is any investment opportunity in the marketplace, any investment, that should be included in the market portfolio, right? So this is where we are going to understand this systematic risk and the unsystematic risk, right? Since the market portfolio contains all the risky assets, as I said, it is completely diversified portfolio, which means the all unique risk, all risk unique to the individual asset is already diversified when you are creating a portfolio with all the investments in the market, right? So that is the main idea. In theory, you can diversify all the risk that you can diversify when it comes to the market portfolio, right? This unique risk, which is often called unsystematic risk. Unsystematic risk means the risk that is attributable for the individual asset. Individual asset. It is for a single asset. It is often by unique variability of the other holdings in the portfolio. So because when we are combining all the assets together, the unique assets will be offset by the variability of the other assets in the portfolio. Like as I said, now when you are combining portfolios, if you are going to receive a loss from one asset, you are going to cover it by the another asset, right? If you are going to make a loss from asset A, you can cover it by the asset B. That is the main idea of the creating portfolios. So when you are creating portfolio, you can always diversify the unique risk of an individual asset by the other assets, the variability of the other assets. So that is it. And this implies that only the systematic risk, defined as the variability of all the risky assets caused by the microeconomic factors. That means not the microeconomics, macroeconomic factors. That means by the whole market, the inflation, the liquidity, the all other factors, right? So it is like this. If this is the total risk, you can see it here. If this is the total risk, you can see when you are increasing the number of assets in the market. For example, if you are going to create a portfolio more than 20 or 24 asset, 20 to 24 asset, that means you can reduce all the diversifiable risk, all the unsystematic risk, the whole portion of the unsystematic risk, and only thing that is remain here is the systematic risk. This systematic risk obviously we cannot diversify because this is beyond our control. We cannot diversify the systematic risk by creating any portfolio because systematic risk is given by the country itself, the macroeconomy at large. So that we cannot, as an individual investor, we cannot diversify the systematic risk by the given by the country and the macroeconomy at large. So that is the main idea in here when it comes to the portfolio investment. So in the capital market line, we have identified a market portfolio which we call the portfolio of all the assets in the market. And that portfolio will give you the highest possible risk premium for a 1 unit of risk that you are going to get from the market for a corresponding risk-free asset for a corresponding risk-free rate. We already know for each and every market in a country, there is a corresponding risk-free rate. Normally, we identify it by getting the 3 months treasury bill rate. So that is the risk-free rate we are normally assuming. 3 months treasury bill rate. So for a given level of that risk-free rate, and if you combine that risk-free asset with the market portfolio, which represents all the assets in the market, you get the highest or the best possible results in the tangency point, where the capital market line touch the efficient mean variance function. Right? At that point, all the risk that can be diversified is already diversified. That means this portion is already diversified. What is left is actually this particular portion, this part. This is the only part that is there. So when it comes to market portfolio, the only thing that is remaining is the systematic risk, right? Systematic risk. Therefore, we cannot calculate the expected return of an individual asset using this particular theory, right? So that is one of the limitation of this particular capital market theory, because using the capital market theory, if you look at this particular formula, using capital market theory, we can only calculate the expected return of the portfolios. That means the market portfolio and the risk-free asset. We cannot calculate the expected return which is attributable for a single individual asset that has the systematic risk as well as the unsystematic risk. Understood? When it comes to capital market, we can only calculate the expected return of the portfolios that do not have the unsystematic risk part. Because when you are thinking about this market portfolio, you don't have that unsystematic risk. We have already diversified that. And when it comes to risk-free asset, it is always we don't have any risk. No? So therefore, we cannot identify or we cannot estimate the expected return of an individual asset where we have both of the risk, unsystematic and the systematic risk, using the capital market theory. So that is it is basically the limitation in the capital market line, capital market theory. What is the limitation? We cannot identify the risk or we cannot estimate the expected return of an individual asset or for example, security, one stock, or maybe JKH stock expected return. We cannot identify that expected return using this capital market theory, right? So that is the main limitation. So for that particular purpose, we will have to discuss about security market line, SML, where it will give us the theoretical background for us to discuss or to estimate expected return for any security in the market, even for a portfolio, even for the market portfolio, even for an individual asset, any security in the market. But here in the capital market line, we can only estimate the expected return of market portfolio and the risk-free assets, market portfolio and the risk-free assets. So that is the main limitation. So this SML or the security market line we will discuss in the next